Okay, let's start the webinar. A very good afternoon to everyone and a warm welcome to all our guests joining us today. Thank you for being a part of this exciting webinar on Leitech Gauging Solutions. I'm Uma, Marketing Manager at Trimaster Metrology, and it's a pleasure to have you all with us today. Before we begin, we would like to extend our sincere thanks to our OEM partner, Leitech Gauges, for their continued support and collaboration in bringing practical, shop floor focused gauging solutions to our customers. To lead today's session, it gives me great pleasure to introduce our speaker, Mr. Rohit Punekar, our product manager. Mr. Rohit brings strong hands-on expertise in precision measurement, and he is known for simplifying complex metrology concepts into practical, easy to implement solutions. He works closely with customers across industries to help improve accuracy, to reduce rework, and build confidence in every measurement. Moving ahead, I'm also happy to introduce Mr. Mandeep Singh, our another product manager based in Ludhiana. With strong on-ground experience in precision measurement, Mandeep is known for breaking down complex metrology challenges into clear, workable solutions. We are also delighted to have with us Mr. Venkat Srinivasan, our COO, whose extensive industry experience and strategic leadership continue to strengthen our metrology offerings. He'll be supporting today's webinar and contributing to key discussions and participant queries. With that, we'll be getting started now. Over to you, Rohit. We are excited to hear from you. Thank you.
Are, are we audible to everyone?
Yes, audible.
Hello, good afternoon, everyone. Today we are here to gather you for to show our very interesting product like Leitech thread depth instrument. Leitech is a Danish-owned company, family-owned company, and Mr. Leif Larsen invented the combi gauge in 1983, and he has awarded the prestigious Danish Design Award. Now, Mrs. Charlotte Jensen is the CEO of Leitech Denmark. Over the last 10 years, they are manufactured another three types of gauges: high-res gauge, then DG gauge, then DMG gauge. Let's see one by one. Here is one of our combi gauge. I mean, we have demo Leitech gauge, combi gauge, having main telescopic sleeve, having 0.5 mm resolution, DG gauge manual. Another one, high resolution gauge with manual main scale and vernier scale, resolution 0.1 mm. In another we have DG gauge, DG with manual main scale. You will get the resolution 0.01 mm. The fourth one we have DMG, digital with motorized, having forward and reverse motion with resolution of 0.01 mm. Forward and reverse, you will see here. Okay.
So, Rohit, I have a question that you can probably answer for the audience. So, what is the fundamental difference between this Leitech and normal plug gauges?
Since Leitech, they have invented very strongly for in single operation, you may check go gauge and with depth, measuring with depth.
Okay, so depth is
Right,
compared to the normal. Okay.
In single operation, you will get the bow and no bow, and another one's depth.
Okay. And does Leitech, so are they, do they, the inserts for the go and no go gauge, they are getting from elsewhere or?
No, generally they are all manufactured with a special material, and they have invented worldwide number one company of worldwide in lighting. We have a combi gauge with M6 having a main scale reading 0.5 mm resolution, and we have demo component M6 by 1 mm pitch. Okay, everyone can see. Just I will insert the both side in the component. We have M6 gauge, combi gauge, M6 by 1 mm pitch. Okay, and I inserted the combi gauge in our demo component, and now we get the depth 12.25 something. Okay, directly we will get the reading on main scale with this combi gauge. And if your requirement is higher than this model, then we will show you the another gauge which we have Leitech high-res gauge. Its resolution is 0.1 mm and main scale like vernier. Okay.
Yeah, there is a given of the vernier scale.
1.5 mm.
Sorry, hang on, there's a question.
Please go ahead. There is a given of the vernier scale. Yeah.
Yes, this is a version with the vernier scale. The first one was a simple scale with 0.5 mm resolution. This one
Like
is
as a conventional.
this is a vernier scale with 0.1 mm resolution. Yeah.
Yeah, correct.
We have M12 by 1.5 mm pitch. We have a demo component M12 by 1.5 mm pitch. Just I will do this for guide. Then
I think you're not straight.
see, just hand tight. Okay.
No, maybe you can lift it up and show the reading.
See, here you will get the locking screw. You may lock this main barrel sleeve like this, and you may turn back, and you may see the results. Like, see, main scale reading is on 12, and vernier scale is on 0 only. Then its reading of the depth is 12 mm. Okay. In high-res gauge, you will get this locking of the barrel with vernier scale, which you have 0.1 mm resolution. Okay. If you want
Mr.
another,
Mr. Rohit, I have one query. See, you are showing, demonstrating basically to check the depth of
Yes.
the threaded part, right?
Yes.
So usually we also use our height gauge or
Yes.
maybe the vernier. So what's the difference between the two?
Yeah. So see, basically, this is very useful for a few different applications. One is, see, there is with when you want to measure the depth of blind holes, or whether it may be a plain hole, it may be a threaded hole, right? Typically, the depth measurement
is, as you rightly said, you can do it with a height gauge or you can do it with a depth vernier. But generally, the accuracy of those measurements is quite low. Now, over the last several years, there have been an increasing number of applications where designers are calling for tighter depth tolerances of blind holes also. So in such cases where, the tolerance, all said and done with depth vernier, even the repeatability of an operator entering it into the hole, keeping it vertical, etc. It is, the repeatability, reproducibility can be quite bad, really. So this is a gauge that will give you much stronger repeatability and reproducibility. So this is one. There are also certain special geometries. For example, even in plain holes, let's say if you have a hole which has a which ends in a shoulder with a very small shoulder width, even with a height gauge or a depth vernier, you may not get, the land may be very small, where you're not able to touch properly to get a good height gauge, get a good depth measurement. In such cases, you can use these Leitech because it's a sleeve that's meeting at all 360 degrees around the circumference. Even the smallest land, you will be able to sense and measure the depth very accurately. So that is, you can say, the difference between this and the more cruder methods of depth measurement. There is also one more case at the end of the presentation we will deal, so these are cases where what we are saying is it is a design driven, choice of this gauge. That is when the designer calls out for a tight spec on the depth, then you want to use Leitech. This is application one. There is another use case also, which is, forget the designer. Even if the designer had not specified a very tight tolerance for depth, as a manufacturing engineer also, there is a case that can be made for why you should have a process specification for depth, where it reduces manufacturing cost. So at the end of this presentation, we will be sharing a very small case study related to that also.
Yeah, thanks, Mr. Siddharth. It's clear now. Thank you. Yeah.
Yes.
I forgot to show you another thing. I shown you the go side. I forgot to show you the no go side. Just you may see the no go side here, no go side here, and go side here. Okay. If suppose no go is not going and go is goes, then this is
the hole is qualified. Yeah.
Yes, qualified. If you want better accuracy than high risk gauge, then you may go to our third model type of name is DG gauge. You may directly give the results on display. Also, this gauge is having locking screw of main barrel. Okay, telescopic barrel is there, and now we have M8 by 6H having here M8 by 1.25 mm pitch. Okay, then just I will guide here and just tightening the. Okay, here you will get the results, and if you are unable to see the results, then you may lock this barrel and turn back the gauge. Now you may see the depth of the this hole. Then you will get the result 9.45 mm, having 0.01 mm resolution. Okay. Also, this gauge is having no go side. Another one, we have a very beautiful product, DMG, digital with motorized, having display with 0.01 mm resolution, and if you may see, having battery cells, 3500 mAh battery is there, having torque with variable
torque control.
Variable torque knob.
8 Newton per centimeter.
Sorry, was there a question?
Yeah, variable torque knob is backside. of the instrument.
Yes, correct,
Yes.
correct, correct.
With the 5 different types of torques values are there, na? Yeah.
Yes,
Yes, yes.
correct. It is for the different, how do I say, for different thread sizes. Basically, you know, and based on the fit class that of the specific thread you are driving in, Leitech has done, you know, some studies on how much torque it takes to drive the thread gauge into the, you know, into the hole, and so they set up, because this is motorized. So the operator doesn't really have a feel for, you know, if the go gauge is going very tight or loose. So they have that torque specification, so that if the hole is machined a little small, and if the drive is crossing the torque limit, it will not be able to drive it in.
Yeah. Yes.
Yeah, go.
Uh, we have DMG gauge forward motion. I set the torque on 8 mm because we have M8 M8 by 1.25 mm pitch. Okay. You may see like this, forward and reverse.
Yeah.
Okay. Another we have for barrel. You may do like
Yeah,
this
Rohitji.
for guiding purpose.
Yeah,
And
Rohitji.
Yes.
yes,
I think you need to set the torque at a 16 Newton meter, because the Leitech recommending upon the size from 7 mm to 12 mm, the recommended torque is 16 Newton
16
meter.
Newton per second, yeah.
yes, 16 Newton meter I have set.
Yeah.
You may see.
Otherwise, it will not take a load to rotate
Yes,
the thread inside.
just I guided this hole on our demo component and doing forward motion. See like this, then you will get results over here. I'm pulling it back in reverse motion, just like this. This gauge is using to avoid the manual pushing and pulling out to the inserts.
Yeah, the effort. I mean, you can just show on the same hole how long it takes with the M8, normal M8.
See, if you are going with this DMG model, then within a second you may put the insert inside and pull back within a second. And if you go with manual, then it will take almost 3 to 4 seconds for 9 mm.
It took even more. It took almost 7 or 8 seconds just to put it in,
yes,
pull it out, and not to mention also the you know, the load on the wrist and the fingers. So where you have to do many times a day in a production environment, there is a very strong case to be made for DMG instead of one of the manual gauges.
This DMG gauge is very useful in production line where you have multiple types of gauges, and it is battery operated. Having the battery 3500 mAh rechargeable batteries you will get with flexible inserts. Okay. On slide you may see the different types of handles, T200, 300, T400 to T700. Like these handles you will get. If suppose you have one M2 insert and another one is having M8 and another one is having M6 or something, then you have to choose the single handles. But if you have in between M7 to M12 the range, just you have M10, M8 and M12, then you have to just one go to M10 handle, and you may change the inserts M10 by 1.25 or 1.5 something, or M8 by 1.25 something. Just you may change the inserts, but you generally you goes with continuous changing of inserts, then you may just take the separate hand. Okay. Here you will get the depth of the combi gauges with different handles. 2 to 10 mm for 200 handle, 2 to 24 mm for 300 handle, 40 mm for 400 handle. The different sizes you will get on this slide. As per your components, you may decide which you have to go with and what accuracy you require. That way, we can suggest the model and inserts.
But also to mention, these are the, on this slide, these are the standard height ranges. So for example, if I buy a T300 handle, the standard depth range is, it can accommodate up to 24 mm depth holes. This is the standard. However, you have special geometry holes. Leitech is able to make special handles for whatever is the hole depth that you want. So instead of 2 to 24, if you want, let's say 20 to 40 or something like that, Leitech will be able to make special handles for that as well. That's not a problem.
Have you seen all this slide?
I think
Just I will go with the video.
max full screen.
Yeah, in these all are the thread insert detachment tools.
Correct. These are what they're showing is how do you insert and remove a thread, an insert from the thing. It's quite easy, as you will see from the video.
To dismantle the inserts, go and no go, it is very easy to handle. As per pitch size, you can adjust this calibration master. As, hello. As per pitch size, you can adjust the adjust on calibration master. For high res gauge, you may see on a screen that is the calibration master.
And the single master can be used for the different type of thread pitches calibration.
Yes, correct. This on screen, you may see this calibration master. No, that you can use it only for high res gauge. iris and combi gauge.
Yeah.
Now you may see DG gauge. In DG gauge, you may see how to calibrate. For DG gauge, you will get separate setting masters like this on screen. Here I will show you on another screen. Like this, you will get the setting master for DG and DMG gauge. For different types of pitches, you will get the different types of calibration masters like this.
So that was the quick look at all the the actual features of the Leitech gauges themselves. So as you know, we discussed at the start as well. What are the benefits of the Leitech gauges? Number one, to summarize, it is a very unique. Ultimately, at its core, it is a go-no-go gauge for holes, right? Go-no-go plug gauge for holes, right? Uh, but the one difference is, so Leitech is number one. They are an excellent plug gauge manufacturing company themselves, right? So when you look at the thread plugs that they make, can you please make sure that focus the videos again? Yeah. So when you look at the inserts, Leitech is one of the companies who makes excellent, very high quality plug gauge inserts, and so they are ultimately they're a thread gauge manufacturing company at core. In fact, they also use the highest end calibration equipment. So they have IAC master scanner, which is amongst the world's most reputed equipment for calibration of the threads. In fact, it goes through and functions as a contour scanner for to scan the entire profile of every thread, which is then checked, verified as per standards, and then confirmed for dispatch. So yeah, as insert as plug manufacturers, they are one of the best in the world. They have the capability to make inserts all the way down almost to M1.4 upwards. And also they have the capability, like this particular insert I'm holding in my hand. It is it's an insert with special coating. So they have different surface coatings also available for if you have need for special wear resistance, etc. So at the core, they are a plug gauge company, but Leitech does not make standard plug gauges at all. They do not make, the plug gauges that we are accustomed to, where the go gauge and the no go gauge are just held together by a solid handle. They are not into that business at all. Their focus is to make these gauges which have inbuilt depth measurement. So the go side has the inbuilt depth measurement, which Rohit has already very clearly explained to you. What are the application benefits? I already said, some of this I spoke about little earlier in the presentation, where there are a growing number of applications these days where designers do ask for tighter depth specifications, right? That is one. Number two, there are holes which have the bottom geometry is not a straightforward geometry for us to, if you use the anvil of a standard depth vernier, or if you use a particular, even if you use a typical insert on a height gauge, there are holes which may have very, non-conventional ending geometries. So how do you measure depth of such holes? For example, I will look at this hole. Look at this plug right here. It's used to measure a hole which has a uh, spherical end, right? How do you measure? If a designer has called out such a hole, how do you measure the depth using any kind of standard tool? So for such applications, Leitech is excellent. Um, and one, as I said, one should not think about it as it is. Though the complete demo that we've shown today focuses on threads, that does not mean Leitech makes these gauges only for threads. Any kind of special geometry, plain holes, or standard threaded holes, Leitech is able to make gauges for. For example, if I look at this demo component, right, these are all standard holes, but I also have here on this surface, I have a couple of, so as you can see, just to understand geometry, we have at an angle here, and I have holes which are drilled at an angle. And if I wanted to measure the depth of such holes, Leitech makes special inserts like this with, it's a swivel with a swivel adapter at the end. So you are able to come in here and have this adapter lock onto the component as per the geometry, align the sleeve to the hole, and then push in the sleeve for the depth measurement. So when you have very interesting non-conventional geometries of your holes also, Leitech is quite unique in being one of the only solutions where you can do very accurate depth measurements which are on the shop floor and extremely rapid depth measurements, right? It's not like you're taking this to a CMM, making a program and waiting a few minutes to have the results. It is something that you can equip your shop floor operators, very robust gauges right there. It is, it's as simple as using a regular go-no-go gauge and you're measuring the depth. So that is that's the speciality of Leitech. The last thing that I spoke about at the start of the presentation was also, we said there is a case where, no, can you go to the browser? Yeah, we said there is a case, and can you, Siddharth, focus on the presentation? Yeah. So so far we talked about cases where the designer or the drawing calls out a special geometry or a special tolerance, forcing you to use a better gauge like Leitech for the depth measurement. But let us assume you have a conventional blind hole, right? And you are the manufacturing process engineer. Even there is a case to be made for why you should consider establishing a depth spec for your threads, for your, or a tighter depth spec. So here, this is just a very, very, very quick example, right? On the screen, you can see that we have a particular case study here. Please note, this is, of course, the sheet was filled by Europeans, so the decimal and the comma are flip-flopped. So they've taken a case study where you are measuring, you're cutting about 1,200 holes
on a particular, per day of a particular specification. In this case, they've taken M12 into 1.75. Now, what they've done here is basically assuming a certain feed rate, right, and RPM. They've calculated here what, how long, what is the cycle time taken per millimeter of depth drilling, right? So for each millimeter of additional depth that you need to drill the hole, here they've calculated that it takes about just under 2 seconds per millimeter, right? Similarly, the thread cutting operation, right? Per millimeter of thread, they are calculating that it takes about a quarter of a second per millimeter of thread to be cut. Now you imagine, what is the standard manufacturing engineering approach where the tolerance is not too tight, right? Our standard approach is, let's drill the hole a little extra deep. Let's tap the hole a little extra deep, right? This is a standard approach. Why? Because we want to play it safe. Now, but if you think about it in the other way, what is it that, are you, how much extra unnecessary metal cutting are you doing because of this simple, decision, this very casual decision that let me cut 1 or 2 millimeters extra just so that I know I'm safe, right? But that little casual decision, if you look at that, in this case of 1,200 holes per day, right? And if it is resulting in this case study, you are saving more. If you eliminate, for example, in this case, they're saying they've taken a case where you're drilling 3 millimeters extra, right? Actually, if you think about it, for a case where it is, you have a thread pitch of 1.75 millimeters, 3 millimeters is not even 2 full threads, right? So you're drilling just about 1 3/4 of a thread extra, which is something very more. It happens more frequently than we expect in a typical manufacturing scenario. So if you think, if I'm drilling like even 3 millimeters extra per day, I am actually losing 135 minutes. That's more than 2 hours per day I'm losing in that particular operation just to drill and tap those additional holes. Why? Per minute, really, it means that I'm per millimeter of extra drilling and tapping. In this case, I'm losing 40 minutes. So if, as a manufacturing engineer, if I could establish a spec myself, even if the designer has not called, in my process sheet, I could establish a tighter spec, and then I could use a gauge like this to ensure the operator is, is checking against the spec. You imagine how much, actual operational savings could be realized, across all the, hundreds of holes that we do machine in our various components any day, right? So this is another excellent case study where it shows you how you can think about using these gauges in order to actually drive your operational efficiency. And these gauges are really not very expensive at all. The combi gauge starts at hardly about 20 odd thousand rupees. And, all these manual gauges that are shown in this particular kit over here, they all vary between 20 and about 80 or 90,000 rupees. And it's only the DMG that's about 2.5 to 3 lakh rupees. The motorized DMG gauge. This is about in the range of 2.5 to 3 lakh, depending on what accessories, etc. you have with it. And even that, when you consider a high volume application, your ROI may be, in a matter of weeks for an instrument like that. So that is the quick summary in terms of, what are the benefits of using Leitech. So yeah, with that, you have anything you'd like to add, Rohit? And otherwise, we can open it up for questions.
Yes. Already done, sir.
Okay. So we invite you all to ask whatever questions you have regarding this product. And at the end, we'll just give a short introduction about our company as well. And then we can, yeah. So we're happy to take your questions, please. Sorry. Yes, we can share the recording. I think there was a question asked on chat. We have recorded this webinar, and for all of those who are registered, we will be happy to share the link with you as well. Yeah, link, also the presentation and the various content that we have shown today. We will share all of that with you. So definitely you should consider this. It's a very nice, neat little product, very unique product for a unique set of applications. Not at all investment heavy, but it has the potential to either improve your quality or reduce your unnecessary machining and improve your operational efficiency by a good bit. Really, in terms of investment, it is a low hanging fruit. It is something that any plant management group can take a decision on easily. And again, it's not like you have various options. If you want a very, very simple solution, you have 0.5 millimeter, you have 0.1 millimeters with a vernier, and then you have, for quick operation, you have the Digi. Now, one should also mention that with any of the digital gauges, whether it is this one or whether it is the DMG, they come with Silvac scales, Silvac of Switzerland, and they all come inbuilt with they are Bluetooth enabled. Therefore, not only is Leitech a gauge for your thread or plain hole depth measurement, it is also Industry 4.0 compliant, because the minute you insert the go side into the hole and you measure the depth, you can have that data instantly transferred to your PC at the click of a button. So that means that you can actually have at least a semi-POCIO for your plug. So today, if you think about it, plug gauges, or basically go-no-go gauges, they are totally mechanical system, and the trust is completely on the operator that they are using those properly and certifying the holes or the features for certifying that they've checked it properly, right? But there is no check, there is no proof, right? But with the Leitech, at least on the go side, you have the very fact that a depth measurement can be sent to the PC means that the operator has no way, but he has to drill it he has to push it in all the way there, click the data, and then you see that data. So really, what you have is an Industry 4.0 compliant thread plug gauge as well for the first time in history. So this is another very interesting thing that you should think of. What is the question? Are these gauges set physically available at your Kolhapur office? Yes, we can. I mean, right now, of course, we do have 2 demo kits which keep rotating around India. This is right now in Pune, but yeah, Rohit, who is the product manager for Leitech in our company, he actually is based out of Kolhapur, so he can bring the demo kit to your office anytime as well. Okay, then Uma, would you like to?
Yeah.
Take it.
So,
Take it.
yeah, thanks everyone once again for joining our webinar. And we have your email IDs registered with us. We will be sharing you all the contents which were shared in the presentation, as well as the needed catalogs, along with the demo videos if needed. We will be sharing it shortly in your emails. Thank you. Thank you for joining us.
Yeah,
Thank
please
you,
do send
Venkat
your
ji.
inquiries or whatever you want. Please do feel free to email us for anything. And
Yes.
we are also there in 16 cities around India. So likely we have an engineer close to you. So
Yes. Thank you so much.
Thank
thank
you.
you
Thank you,
all.
Venkat ji. Thank you, Roji.
Thank
Thank
you.
you.
Thank you.